Good morning, good afternoon, good evening. I am Stephen O'Grady. I'm the co-founder of RedMonk. RedMonk is a developer-founced industry analyst firm, and I'm here to talk today with Varun. Would you care to introduce yourself, sir?
Yes. Hi, everyone. I'm Varun Badhwar, founder CEO of Endor Labs. We help organizations adopt open source software more securely and confidently.
Excellent. And that's actually a sort of good introduction or segue, as it were, in terms of our conversation overall, which is, so we're going to touch on sort of the security side, well, some of the key takeaways from a security standpoint. But before we get there, I wanted to sort of get into some of the context that we at RedMonk see in the conversations that we're having, right? So in other words, developers are in an interesting spot today in the sense that they're being pushed to move faster and faster and faster, right? Organizational priorities at this point are across the board on velocity, right? The organization wants to move faster. They're pushing their developers to do that. At the same time, developers are forced to do this with fewer of them, right? We've had layoffs across, sort of a variety of industries. So there's fewer actual bodies to do the work. And at the same time, they've had more jobs posted, sort of on their shoulders, right? Jobs that used to be sort of upstream or to the right, if you will, of, the actual developer work are now being placed back on their shoulders. And again, the context of all of this, of course, is that, security has never been sort of more of a sort of critical consideration because the attacks get sort of more novel and more sophisticated by the day. So that's the sort of setup. That's the context here. It's not to put too fine a point on it. It's a hard time to be a developer in many ways. And to that end, you all have done some interesting sort of, research and survey work in terms of, okay, what precisely does this mean? What are the impacts? So can you sort of talk about that work and sort of pull out some of the key findings in your view?
Yeah. And so, Stephen, first to your point, I think as we talk to a lot of organizations, the biggest frustration is this kind of what we call the developer productivity tax that security tools and security results and scanning is causing. And in a lot of places, that's ending up being upwards of 50% of the developer's time. So we dug deep to say, why is this happening? And look, I'm sure we've all seen statistics that a majority of our code is now open source. In fact, specifically, over 90% of our code is open source. Now, when that's happening and you're running all of these security scanning tools against that code, you're producing tens of thousands of alerts. In reality, when developers are tasked with manually doing code reviews to uncover if this is a real problem or not, only about 2 out of the 10, meaning 8 out of 10 are false positives. Why does this happen? Because only 12% of the code you're importing from the open source ethos is actually used by your first party application. So think for a moment, if you could eliminate the 88% of the code that you knew wasn't being called in your application, isn't exploitable, you can be so much more targeted on the things you need to go find and fix out of cycle versus things you'll just fix in a regular release cadence as an engineer.
Yeah. And that's, one of the, I know sort of dating back to my own days as a developer, part of it was, God, we had this so many times where, QA would come back and say, hey, we have, sort of X issue or, sort of the bug fix and so on. And you'd sort of dig into it, you'd take it apart for a couple hours and it turns out, well, guess what? That pertains to sort of an older version of the product and it's no longer an issue and you just wasted a bunch of your time, right? So this is a cycle that developers know well. I guess my question is sort of what can be done, right? In other words, if we can all agree that, and it should be terribly controversial, right? That, look, we're consuming a lot of open source software. A high percentage of that open source, however, is not actively utilized. It's just present. So, obviously, if we're going to target, security issues and incidents within a given code base, you only want to work on the stuff that's actually relevant and in use. So, Okay, great. I think that's the obvious takeaway. We want to focus on the things that are going to that actually represent vulnerabilities, as opposed to some artifact that somebody imported a while ago and is not used and doesn't represent a vulnerability. So what do we do? Like, what are you, when you're talking to developers today, what are your recommendations?
So first, let's understand the cost, right? Because ultimately developers will want to do things once you can quantify the problem. Right. On average, each time, what our surveys found is each vulnerability that a developer is tasked with reviewing, just to review and triage, to the point of decision of, am I actually going to do something about it or not, is on average 8 hours of time. Okay. So it is not uncommon that you have tens of thousands or hundreds of thousands of these. Let's take round numbers. 10,000 less vulnerabilities to investigate manually is 80,000 development hours given back for you to write code and innovate. Okay, so that's the magnitude of the problem. So why does this problem exist, and kind of what do you as a developer do about it? The root of this problem, Stephen, is the fact that most of the scanning tools around software composition or open source scanning, whatever you want to call it, rely on manifest files. So they'll rely on your package.json, requirements.txt files, and things like that. These are basically proxies, guesstimates to what's the reality in your application. At best, you know what packages are being imported, names and versions, how they're being used, what's dynamically being invoked in your application, through all of the other nuances of languages like Python that are extremely popular with the advances in AI. Is ground reality doesn't exist in manifest files. So where does it exist? Source code, your code as it's being built, is the best source of truth. That's the ground reality of what's happening. So if you, instead of scanning manifest files, can scan the information in your source code through static analysis, now you have a very fine-grained set of specific findings of what's actually happening in your code and what do you care about. And beyond that, you can apply layers of prioritization like exploitability, maturity of those exploits. Is this code even available and running in production, or is this just in tests? Have you shipped this release to a customer? There are so many mechanisms that you can apply. And what we find on average is when you do that, you can get rid of 90% of the noise. And the 10% of the things that remain are the things that you have evidence for of how exactly this is happening in your code. So one, the time saving comes from the majority of those findings that you don't even as a developer have to investigate. Okay, so that's step one. The other benefits on cost even come from just the ease of processing the information provided to me. Okay, where is this in my code? Where's my first party code calling this dependency? What is the path to upgrading it? What is the impact? And so furthermore, for the things I even want to act on, if I can give you more confidence on how and where to act upon that, we are looking at millions of dollars of savings in a typical open source program kind of governance model. So true savings for enterprises of any scale and any magnitude. If you have a handful of developers all the way to hundreds of thousands of engineers.
Yeah, I mean, it's the analogy I would use for it's almost like a sort of intake nurse, right, in an emergency department, right, where it's okay, you have to sift through the actual sort of critical injuries versus the ones that are like, hey, you're fine, right, here's some aspirin, go home. We don't need to see you. And, that, at scale, particularly the scale that we're talking about here, where, there are, some of the larger organizations are going to have tens, if not hundreds of thousands of developers. The math gets pretty compelling there pretty quickly, for literally saving them an hour a week, let alone, 8, sort of or more, sort of on an incident basis. So that seems, sort of pretty straightforward to me. I guess what we'll sort of, leave with here is, if you are talking to an enterprise, right? If you're talking to an enterprise that employs however many developers, small team, large teams, anything in between. And, the argument is clear to them on paper, right? Okay. Yeah, I understand that there's a better way to focus my time, my resources, my developer essentially availability. What's the next step? Like, where do they go? What do they do? Like, how would you recommend, sort of they go about, getting their sort of basically handle on the issue of all of this time wasted?
Yeah, look, I think this is kind of where a lot of the Endor labs focus on product development and what we offer to our customers is we are very proud to say, go out there, look at your existing tool that's scanning your manifest files, take your quote unquote best in class SCA tool that you use, and then go run Endor labs against a similar environment or same code base and go see here's what you're typically going to find. You're going to first find that the accuracy of just even the inventory of what's being used is so much better when you do it through static analysis versus manifest files. So the accuracy of knowing what dependencies you rely on, both direct and transitive, is much higher. The second piece is the prioritization. You will see that in action. But Stephen, the third piece we haven't talked about is, as an engineer, security issues are bugs, right? But there are other bugs and concerns I have with my code. Things like maintainability. There's another important statistic worth calling out here. 62% of the time, once we import an open source package, we don't go back to upgrade it or update it. And there are lingering, we have a saying, open source software ages like milk, not wine. Right. So if you're thinking you're going to have this code base, it's like everything else. You have to maintain it. You have to update it. You have to know when to update it, find the best paths to update. And so those are the kind of things we're really highlighting to engineering teams is understand what's in your code. Understand when's the best time to update. Flag issues when somebody's falling behind. Because this is all tech debt at the end of the day, right? If I'm not doing something, I'm 67 releases behind on an open source library that's critical to my web application. That's a problem because tomorrow, if my pager beeps and something's down, I don't have an easy path to update 67 releases in one shot. So I think these are the kind of issues that really are front and center to software development. And yes, open source is free, but it's not really free because you have to put in the time and effort to maintain, manage, and nurture it.
So you're saying there's a better way to approach things than handing your developers, I should say, a list of thousands of theoretical vulnerabilities that have turned up in a scanner. That's
correct. There's a better way than that, and there's a better place to scan, which is not your manifest files. And I can go into so many reasons why manifest file-based scanning as your ground reality is so wrong.
Well, we'll have to hold that for a future conversation. Varun, really appreciate you stopping by to talk to us about this. This has been great.
Thanks for having me, Steve.